Hi everyone, I'm PRANAVJI and I'm from PSG College of Technology. So I participated in the RECode competition and I did a coding problem which given by RECode, which they are given by the coding club in the RECode competition, and I will be explaining that problem now. So let's go. So the problem statement is Jas is working on a problem related to binary trees. So he wants to determine if a given binary tree is a sum tree or not. So a sum tree is a special type of binary tree. The value of each node is the sum of values of its left and right subtree nodes. So basically what subtree is, the value of the root node is equal to the value sum of the left and right subtrees. So the task is we have to write a program to assist Chas in determining whether a given binary tree is a sum tree or not. So let's see the input format. So the first line contains an integer which represents the number of nodes in binary tree, and the second line contains an array values which are separated by spaces, and the output format should be on the first line we have to print the level order traversal, which is nothing but the breadth first search, and the second line we have to show whether the given binary tree is a sum tree or not. So as I have said already that the sum tree is nothing but the root node value which is equal to the sum of the left subtree and the sum of the right subtree. So let's see the coding constraints. So the n value must lie between the values 1 and 15, and the array's values must lie within 1 to 400, and the binary tree is not empty. So these are all the code constraints they are given. So now let's understand how to approach this problem. So let's take some sample cases, like let's say the root node is 44. And then the left subtree value is 9, and then the right child is 13. And then the left child value is 4, 5. Okay, let's consider this test case. So where the root node has 44, and then the left child contains 9 and the right child contains 13, and the left child of 9 contains 4 and right child 5, and then followed by the left child of 13 is 6, and then the right child of 13 is 7. So what the sum tree is like? So the root value is 44, right? So the sum of the left subtree is 9 plus 4 plus 5 is 18, and then the sum of the right subtree value is 13 plus 6 19 plus 7 is equal to 26. So combining these both sums, we are ending up with 44, right? So this 44 is nothing but the value of the root node, so which is nothing but this tree is a sum tree, right? So this is how we are going to approach the problem. So now let's see how to implement the. So on the first line I have imported the math module, and then next I have given a defined a function total, which is nothing but it calculates the uh, left subtree sum of elements, and then the right subtree sum of elements. So after that, first we will come to the main function. So here I am getting the input of n, and then here the t is nothing but the n space the integers which we are getting from the user, and then here what we are doing is actually we are getting the values input values as string in the format of string. So here we are implementing the split operation, and then it converts the string into list, and after that we are storing these values inside the list known as tree. So we are converting the strings as integer values. So that's what we are implementing over here. All right. So after that we are checking some base conditions, like when the length of the tree is 1, then we simply say that the binary tree is a sum tree, and then after that we are printing the level order traversal, which is nothing but the breadth first search. So it's simply like traversing the elements one by one. So like it goes like this. So from the root node is 44, and then 9, and then 13, and then 4, and then 5, and then 6 and 7. So the level order traversal would be 44, 9, 13, 4, 5, 6 and 7. So this is how the level order traversal will take for this binary tree. Alright. So then after that we are calling the function inside this result variable. So here we are calling the total function. So now let's see how this total function works. So basically what we are doing here is, so we are getting two parameters, like we are importing the tree array, I mean the tree list, and then here we are having the index variable which contains the value 0 initially. So it is basically nothing but we are starting from the root node value. So here in the if condition, when the idx value is greater than the length of the tree list, then we are returning the value as 0. Alright. So after that we are using two variables, and one is left and then one is right. So basically what we are doing is, for left we are implementing equation like idx into 2 plus 1, and for right we are implementing idx into 2 plus 2. So what is this idx into 2 plus 1 and idx into 2 plus 2? So basically it's nothing but, here from the root node we are starting with 0, and then in the left subtree we are considering as index 1, and then this index as 2, and then this index as 3, and then this index as 4, this index as 5, this index as 6. So basically it's nothing but we are calculating it as level wise. So this level is 0, so this level is 1, and then this level is 2. Alright. So we all know that the height of the binary tree is nothing but log n, log base 2n. Alright. So basically what I'm trying to say is, for the left subtree we are implementing like I into 2 plus 1 for the left subtree. For the right child we are calculating it as I into 2 plus 2. Alright. So this is how we are calculating the index for the left child and then for the right child. I value is nothing but the parent's value, index value, which is nothing but, for the left child it goes like this. So I value is 0, and then into 2 plus 1 is 1. So this is the index value of the left child, and then for the right child it goes like this. So 0 into 2 plus 2, which is nothing but 2. Alright. So followed by, for the third index we are taking it as the I value as 1, and then into 2 plus 1, which is nothing but 2 plus 1 is 3, and then after that for the right side we are taking it as I value as 1 into 2 plus 2 equal to 4. So that's how we are arriving to the indexes of the left child and right child of a particular nodes. So this is how it works, and after that here we are recursively calculating the left sum and the right sum of the binary tree. And here, when the root value is not equal to the sum of the left subtree and the right subtree, we are returning the value as -1 in this function. And after that, when the left subtree sum and the right subtree sum when either of these values is not satisfying the root node value, then we are returning it as -1. So both of these conditions are not satisfied means then we are returning the sum of the root node values and the sum of the left subtree value and the right subtree value. So this value is stored in this result variable, right? And after that we are implementing an if else condition, so where when the result is not equal to -1, then we are concluding it as that binary tree is a sum tree, and then if the condition is not satisfied, then the binary tree is not a sum tree. So this is how we are calculating. So let me run this for you. So let's consider this example itself. So we are having the number of nodes as 7. We will run it one more time. So 7, and then 44, and then what we are given, and then 9, 13, then 4, and then 5, and then 6, and 7. So see, so this is how the level order traversal is being done. So basically we are just iterating over the elements. So that's how the breadth first search is done. So basically it's a level order traversal. So from level 0 we are printing it as 44, and from the level 1 we are coming from the left to right, and this is how the level order traversal is done. And here you see, so the binary tree is a sum tree. So just as we have just as I explained to you that this tree is a sum tree, so the left subtree value is plus the right subtree value is equal to the root node value. So hence we can say that the tree is a sum tree. And yeah, that's the problem. That's the conclusion of the problem. Thank you.